Good afternoon. The topic for today is PN junction diode. Myself, Dr. Indu Nayarvi from the Department of Artificial Intelligence and Data Science, SNS College of Technology. Today we are going to discuss about PN junction diode. So what is a PN junction diode? So we are going to discuss about semiconductor, P-type and N-type material, then how a diode conducts and what are the applications of the diode. So we are going to discuss the construction and operation of diode, types of bias, then role in real-world industries. So a PN junction diode is a two-terminal semiconductor device formed by joining P-type bracket holes and N-type electron materials, creating a junction with a depletion layer. It acts as a one-way valve, allowing current in the forward bias and blocking it in the reverse bias. Construction materials formed from a single crystal of semiconductor, silicon or germanium, doped with acceptable impurities, p-type on one side and donor impurities, n-type on the other side. Junction. The interface where the p and n-type material meet is called as the p-n junction. The interface where P and N materials meet is called the PN junction diode. Terminals, the P side is connected to the anode and the N side is connected to the cathode. So, two-terminal semiconductor device works on the principle of unidirectional conduction. So it is a two-terminal device. One terminal is termed as the anode and the other terminal is defined as a cathode. The symbol, you have a triangle that represents the anode and the straight line which represents the cathode. Working of PN junction diode. Unbiased. In equilibrium, the potential barrier prevents current flow. So a potential barrier is formed which is called as a depletion region. The N-type electrons move on to the p-type and in between they recombine to form the depletion region. It is called depletion region because the entire region is depleted of charges. When it is unbiased or no bias is applied, a wider depletion region is formed which does not allow the further movement of electrons from n-type to cross over the p-type to form a current. Forward bias. Then the positive of the battery is connected to p-type and the negative of the battery is connected to n-type. We have what is called as a forward bias. The external voltage opposes the potential barrier, narrowing the depletion layer. Electrons move from the N side and holes from the P side to the junction, allowing high current flow. So the N-type region, electrons are the majority carriers and holes are minority carriers. In the P-type, holes are the majority carriers and electrons are negative charge carriers. Because of concentration difference, majority carriers diffuse and recombine with opposite charge. It makes a positive or negative ion. These ions are collected at the junction and this region is called depletion region. When an anode terminal is connected with a positive terminal, cathode is connected with negative terminal, the diode is said to be connected in forward bias. Now gradually the supply voltage is increased and if we increase a small voltage, majority charge carrier does not get sufficient energy to cross the depletion region. In the forward bias condition, the width of the depletion region is very small. Hence the majority carriers cross over. So if we increase the voltage more than the forward breakdown voltage, which is called as the V gamma or V cut-in voltage, the majority charge carrier get enough energy to cross the depletion region. For the silicon, the forward breakover voltage is 0.7 and germanium, the forward breakover voltage is 0.3 volts. When the supply voltage increases more than this voltage, majority charge carriers flowing through the circuit and it makes the diode in the conducting mode. In this mode of operation, a very small amount of drop occurs. This drop is known as on-state voltage drop. The connection diagram is shown in the module. Reverse bias. The diode is connected in the reverse bias. In this condition, free electrons diffusing into the p-type region recombine with holes. It will create negative ions. Similarly, holes diffuse into n-type region, recombine with electron. It will create positive ion. When such voltage is applied to the circuit, immobile ions create a depletion region as shown in the above figure. The width of the depletion region is large, hence no more holes or electron cross the junction. It cannot create a flow of electrons or holes even if it is applied at rated voltage. However, it is not possible to flow the current through the diode and it behaves as an open switch. So in the reverse bias condition, the current is known as reverse saturation current or reverse leakage current. This current flows due to the minority charge carriers. This current is not high enough to conduct the diode. If we increase the voltage up to the reverse breakover, the minority charge carriers get high kinetic energy and collide with atom. In this condition, the number of covalent bonds broken and a high number of electron-hole pair generate a huge amount of flow of current. Application of PN junction diode. PN diode is used for rectification. Zener diode is used for voltage regulation. LED is used for lighting indicator. Schottky diode is used for high speed switching. Photodiode sensor is used for sensor and communication. So books for reference is Integrated Electronics, Millman and Halkias. And websites electronicstutorials.ws, electronics for you, learn about electronics.org. Thank you.